Imagine this. Two people apply for a job. One person gets the interview while the other does not. Both of them actually have the same qualifications. When asked, the company stated that the hiring process has AI in it, meaning that an automated system filters employees. We like to think of AI as a neutral, logical, above human flaws system, but this might be one of the most dangerous assumptions out there. Let's find out why. AI doesn't live in some clean, unbiased vacuum. It's messy because we're messy. The data we give it are biased, and the decisions we make regarding it are moral ones. The tools we build and use reflect the world we live in. Hello, everyone, and welcome to May I AI, a series designed to make AI more accessible. I am your host, and today we are talking about bias in AI. We are going to explain in technical terms where it comes from, what it is, and how it's deeply tied to psychology and human social history, and how fixing it just might start by looking inwards. Let's start with the basics. What do we actually mean when we talk about bias in AI systems? In machine learning terms, bias is a systematic error. It means that your model favors an output or a certain pattern over another. This isn't because of malicious intent, but because of the data the model was given. Let's take an example to clear things up. Let's revise the example we talked about in the previous episodes regarding the model distinguishing between cats and dogs. During evaluation, we saw that the model predicted 90% of all images as dogs. We looked at the evaluation dataset, but it was split evenly. That means half of them were cats and half of them were dogs. So we expected the predictions to be a bit more evenly distributed between the classes. When we wanted to check what the error was, we also went to check the training dataset. However, we realized that it was highly unbalanced, meaning there were more dog images than there were cat images. Then we would say that the model is biased towards one class over the other. It has a higher chance of detecting a dog than a cat. But why does this actually happen? You see, when you have too many images of one class and too less of another, the model realizes that the best strategy of dealing with things is to assume all of them come from the same class, because this is way easier than trying to learn the nuances of detecting the smaller size class. Think of it as a lazy student. In an exam of 100 questions, imagine only 5 questions had different answers. It would be way easier for the student to assume all of them had the same answer than try to learn and figure out the answers to these 5 different questions. Because assuming all of them are the same one just guarantees 95% accuracy, assuming you pick the right one. And this is basically where bias in AI systems come from. If you're trying to train a model to detect birds but only use parrots, the model might learn that if a bird is not colorful, it is not a bird. Bias is when a model learns distorted views of the world due to imbalanced data. Now here's the catch. Most AI systems in today's world are trained on large corpus of datasets. This includes social media, books, movies, series, resumes, and so on and so forth. And the real world is by no means fair or unbiased. It contains stereotypes, inequalities, and historical imbalances. Let's take in two more examples. We talked about the hiring algorithms, where some companies use AI and automated systems to filter job candidates. We would realize that most AI systems rank male applicants higher than female ones. This is not because the models or the AI are sexist. This is due to the fact that the data show a statistically male dominated industry. The model is simply following the same pattern as it sees in the data. Another example would be predictive policing, where some countries decided to use AI to decide which places in the cities have more rates in crime. However, the data is based on where more patrols have gone in recent years. So it's based on where the police have historically patrolled before more often. And this is usually in minority spaces and low income neighborhoods. So the system reinforces the pattern by sending even more patrols there, which in turn leads to having more data and more patrols in that area, which leads to even more bias as we retrain the model even further. So in all cases, the model isn't biased by itself. Bias isn't something that the AI invented on its own. It's inherited, not by the way we think of fairness and ethics, but by mathematics done over flawed data points and inputs. And this is why AI in today's world isn't objective. It is flawed because it learns from the data we give it. And the data we produce as humans is flawed, biased, incomplete, and subjective. In the world of AI and machine learning, there is this sentence that sums it up very perfectly. We like to say garbage in, garbage out. Whatever you feed the model, you get out of it. So if you feed it really bad data, you get bad data. But more on this later. By now, you might be wondering, if the problem all stems from the data set, can't we just fix it? Can't we just take our data that we're using to train the model and remove all of the bias from it? And you would be right. To an extent, this would be a solution. But in reality, it's a lot more complicated than you think. See, bias isn't just a technical glitch, it's a reflection of human nature. And while some cases might be very easy to decide on, others might be impossible. What some minority of groups might see as ethical, another might think it's not. While some people might think something is just, another people might think that this is favoritism. What is acceptable to one culture is completely unacceptable by another. And this is why picking up bias from a dataset might be fairly impossible. Because the first step in removing bias from a dataset is identifying what constitutes as bias. And in itself, this is subjective. This is why most AI ethicists and people in research say that we don't want a model to be unbiased, but we would rather have a model that is accountable, a model that is able to explain its action and choices and not just be a black box. A system built by diverse teams able to ask hard questions before pushing something to production. Now, to be fair, there are strategies. Of course, there are strategies. There are fairness metrics, unbiasing algorithms, and audits. And all of these, in a way, are made to remove bias from a dataset or balance a dataset. But these are tools. And like any tools, they reflect the people that build them. They reflect the priorities of the people that created them and are using them. So maybe instead of trying to chase the myth of an objective AI, we should chase something a bit more reliable. Not a perfect neutral machine, but a machine that is aware of its own limitations. One that doesn't really hide behind the illusion of objectivity, but leans into the trade-offs and its limitations. Let's take a second to look at a real-world example, a use case that happened recently that puts stuff into perspective. In 2016, ProPublica, a non-profit journalistic investigative organization based in the US founded in 2006, published an investigation into a tool called Compass. Compass, the Correctional Offender Management Profiling for Alternative Sanctions, is a tool of risk assessment created by a private company built in 1989. The tool was used in places in the US to help judges in items like sentencing and parole. It was made to assess how likely offenders are to reoffend. In other words, it tried to predict future crimes by the same people. On paper, this sounds like a really good idea. You can reduce bias, use less people, just use data, and there's no more bribing in the judiciary system. However, when the researchers tested this out, they found an alarming fact. The system was twice as likely to accuse some defendants falsely as high risk than others. As you would imagine, the system would assume that black individuals have a higher risk to reoffend than white ones. Here's the twist. The companies that made Compass said that they are not used race in their system, and they were technically correct. Race was not an input to the algorithm, meaning the system never looked at someone's skin color to determine if they're gonna reoffend. However, the system used different factors like education level, zip code, where the person lived, and whether or not they were arrested before, all of which strongly correlate with skin color and race due to the historic inequality. So even when race and skin color wasn't part of the system still developed bias. Bias still found its way in because the data reflected the society that was using it. This case became a wider question, not just about bias in AI, but whether we can split the data from the people that made it. And what if we can't? What if we can split the data? What if we can never make unbiased data? What responsibilities do we have when we design systems that make decisions based on people's lives? Whether it's in the judging world, policing and patrolling, or in hospitals and ethical dilemmas. Now, here's the thing. We cannot just talk about AI and bias. We actually have to also talk about morality. When we build these systems, when we design them, we don't just write code, we make value choices. We decide what is fair and what is not. We decide who benefits and who doesn't. Let's take facial recognition as an example. Let's assume a company is using facial recognition tools for people entering the company. And they realize that the model is performing better on white males than everyone else. And they decide that's okay, we're just gonna go carry on more data gathering. But here's the question: should facial recognition models be used in public at all? This is no longer a technical question, it's an ethical one. AI isn't built in a vacuum. Every decision, what to improve on, what to optimize on, which data to gather and where to gather it, is a decision by a society. It reflects worldviews, priorities, and trade offs. And sometimes, even good intentions can lead to bad outcomes. Here's the simple but very powerful truth is that objectivity isn't the absence of an opinion, but rather the appearance of it. And when a machine makes a decision, people usually assume it's neutral, just, and unbiased, which to an extent it's true. You cannot bribe a machine. You cannot give a machine a better option or, let's say, change its decision. You can by code, but if you already have a machine that is built with no input rather than the facts, you cannot change its decision. However, the system used inside, the way it's built already, constitutes the subjective nature by the people who built it. If it's an AI, it's built by the subjective nature, the bias that already exists within the data. Behind every decision the machine makes, there is a long chain of human choices. Who gathered the data? Who labeled it? Who decided which labels were correct? Who decided which opinions were valued more than the rest? And more importantly, who evaluated it? In a way, AI systems are a mirror, not just to the data it was trained on, but to our values as humans and the humans who trained it. And if we are not careful, we're not just going to create AI systems that are better, they're also going to learn the human blind spots and subjective natures. And this is why ethical foundation of models, the ethics of AI, shouldn't just be a nice to have or an option to add. It should be a foundation. It should be built within every AI system, especially today when AI systems are getting more intelligent and more integrated into society. A lot more people are using AI systems now in various ways. At this point, it's very easy to get overwhelmed. If bias is everywhere, it's in our system, it's in our data, it's in our life, what can we even do about it? And the first step would be awareness, realizing that this is a flaw in all systems. While AI is math and code, it's also people. It's shaped by history, culture, and assumptions. And these are in all tools, especially the ones we use in our day-to-day lives, like LLMs, GPT, and Claude, and Gemini. They all contain the same problems. LLMs are trained on a great corpus of data set. This includes encyclopedias, but also random text on the internet, which includes vast stereotypes about everyone. They also get refined based on human feedback, which means people's subjective natures also influence the model outputs. So what can we do about it? For researchers, for developers, it honestly means being careful. It means making more audits, testing your software very well, adding ethics as a foundation to your systems, and making sure that your team is diverse enough to not have a single subjective thought. For everyone else, for day to day users, it's all about awareness, knowing that systems contain these problems, and not just getting information from a model or AI as if it's a neutral, subjective, logical output, but that it also contains some bias within it, no matter how small or how big. So it means stay curious and stay critical. Ask the right questions. Ask more questions. Don't be afraid to ask who built this? What did they use? Which data? Where did it come from? These are important questions. Bias in AI is not just a bug to be managed, it's a reality we have to acknowledge, we have to be aware with. So, as we wrap up today's episode, here is the takeaways that I want you to take home with you. AI doesn't live in some clean, unbiased vacuum. It's messy because we're messy. The data we give it are biased, and the decisions we make regarding it are moral ones. The tools we build and use reflect the world we live in, for better and for worse. But this doesn't mean we're powerless. The more we understand how these systems work, the more we are aware of the flaws that it have, the more control we have over them and the less control they have over us. Because making AI more fair, just, and unbiased is not a technical issue, it's a human issue. It's about us. But that will be all that I'll say in this episode. If this sparked any questions, frustrations, or any ideas, I would love to hear them. Next week, we dive even deeper into AI training by talking about data, about the misconceptions that gathering more data can just make AI always better. If this is interesting, remember to subscribe and send this to someone who might also be interested. Until then, stay curious and ask a lot of questions. Thanks for listening. I'll see you next time.